Okay, everyone, we are on our last week for the year. Okay, so we have 3 more sections of this, and I went ahead and made just a 9-question homework assignment, so it should not take you nearly as long as that last one. Okay, so to start off, we're on 12.4. It asks us what the volume is. You should know that from science class and previous math classes. That's just the amount of space enclosed by a figure. And I do want to point out, it asks what are the units. The units are cubed because there are 3 dimensions to measure. Okay, so 3 dimensions to measure. So for our first fill in the blank here, we have the base of the prism can be any polygon. And our volume is going to be that capital B, so remember that's the area of the base, times our height. So for any prism, that's the case, okay? And then units are cubed, as we mentioned above. And then finding the volume for what's called an oblique prism. So remember oblique, that was in your last set of notes, I believe. That's just when you have a slanted prism. So it's the same exact idea, and the height is always going to be perpendicular to the base. So you're going to see that down here in the cylinders. This right here is an oblique cylinder, but the height is always going to still be that straight up and down from the base, that perpendicular to the base. So we have the base of a cylinder is a circle, and its area is pi r squared. So our volume, we can still think of this as the area of our base times our height, but specifically for cylinders, that's going to be our pi r squared times our height. And then again, the formula is going to be the same for the volume of both right and oblique cylinders. Okay. Now we should have, no, this is brand new, I'm sorry. I don't even know how to pronounce it. I think it's Cavalieri's principle, so go ahead and make sure you read that, but it's basically just talking about some cross sections and stuff, but all prisms are going to have the same volume formula, okay? So we're going to go ahead and do numbers 1 and 3 together. I am not going to post a key this time because I've noticed a lot of people they've been missing a lot of stuff that I specifically go over in just the video. So I do have the answers for these 2 problems here for you guys to check your work with, okay? Now, for this first one, we do have an oblique prism because it's slanted. So remember, our height has to be perpendicular to that base, so that's going to be what I just put here in orange, okay? So for our height, we're going to have to end up using Pythag. Here we see that our slant height is 17, and this looks like a parallelogram. So we know that that is going to be 17 over here. So now we're just going to use our Pythag like I mentioned. So we're going to have 3 squared plus h squared is going to be equal to 17 squared. And if we go ahead and solve for our height that way, we should get the square root of 280. And reason I'm not going to have a decimal answer for this is because I'm going to use that to find my volume, and I want to be using the exact answer rather than a rounded version. So again, our volume of a prism is going to be the area of our base times the height. So here we can see that our base is just going to be that 5 by 5 parallelogram. So we'll have 5 times 5, or I should say rhombus, not parallelogram. 5 times 5 times our height, which we just found, which is going to be the square root of 280. And if you enter that in your calculator, we should get about 418.3. Okay, and then again, make sure you have your units, and in this case, we did say we're going to have cubed. Okay. Now, moving down here for our bottom one. Oh, hold on, my thing froze. Moving down here for our bottom one, though, let's see, hold on. Here we go. Okay, we have a pentagon, and I'm going to go ahead and say that we can assume this is a regular pentagon, meaning that we know that all of those side lengths here are going to be equal to that 10. Okay, so to find the area of our base, we need this right here that I just put in orange. Remember, that's called your apothem, so we'll call that A. So to do so, we are going to go ahead and draw in this triangle here, because remember from earlier lessons, we can find this angle that I just colored in, our central angle. And to do that, we would do our 360 divided by how many sides we have, which is 6. So we would get 60. But I want to focus on finding that apothem length, so I'm going to focus on just one of those right triangles, which would mean that this angle here is 30, since we know both of them together have to be that 60, okay? So we know that this length down here is going to be 5 because half of 10 is 5, and we're looking for that A again. So here we have an opposite and we have an adjacent side to our angle. So out of our sine, cosine, and tangent, tangent is the one we're going to use because that deals with our opposite and adjacent. So tangent of 30 is going to be equal to 5 over our apothem length, okay? So I'm going to go ahead and solve for that and tell you that our apothem, we're going to get about 8.66 for that, okay? So then for our area of that whole pentagon, remember, so maybe I'll put a capital B here, our area of our base. That's going to be your 1/2 times your apothem, which we just found, times your number of sides, so in this case 6, times each side length, which is 10. Or we could say 6 times 10, that's the same thing as your perimeter, remember. Okay, so if we go ahead and multiply all of that out, we're going to get 259.8 roughly. And then we're not done there, we still need to find the actual volume. So we're going to do the area of the base, which we just found, that 259.8. And we're going to go ahead and multiply that by our height, which we can see is 3. And once we do that, we should get 779. Here I have 0.42. I used I didn't round to the nearest hundredth in my key, so you might have, it might be a little bit off here. But about 779.42, and then we're going to do our yards cubed. Okay? So you guys go ahead and do those last two there, and then submit these notes, and I'll be back with the next section.